In this video, we're going to do an example of finding an exponential model. So I want to begin with the definition. We say that an exponential function, or sometimes we call this an exponential model, has the form f of x equals a times b to the x, where the a, capital A, and b are reals, and the number b is a positive number. Okay, so I'm going to highlight this. I'm going to highlight this form. This is the form that an exponential function has. So the key thing that makes this an exponential function is the fact that the variable, the x, is in the exponent. So let's look at an example of an exponential function and its graph. So for example, f of x equals e to the x. This is an exponential function. And you may have seen the number e before. So e is an irrational number. The first few decimal digits are 2.718, and then it keeps going after this, but those are the first few decimal digits. And the graph of this exponential function will look like, it goes through, when you plug in 0 into it, the output is 1, that's the y value, and to the right hand side of 0, it increases more and more and more quickly. To the left-hand side of 0, it gets closer and closer and closer and closer to the x-axis. So it sort of has this horizontal asymptote. And that's what the graph looks like. All right, so let's do an example. There are 83 bacteria in a culture after 2 hours, and there are 151 bacteria after 7 hours. Find an exponential model, b of t, for the number of bacteria after t hours. All right. So the first sentence here describes some numbers. Those correspond to certain data points that would lie on the graph. So the variables here, one of the variables, the one that I'm plugging into my function is t. So that's going to sort of be like my x value. Instead of x, I have a t here. And the output is this thing b of t. B of t represents the number of bacteria. So let's see if we can take the numbers that we see here and write them as a point, like an x comma y type thing. So when it says that there are 83 bacteria, 83 is this value, the thing that is b of t, and that's after 2 hours, so 2 goes in for t. So that's certainly one data point. And can I do the same thing for another, to get another data point? So it says that after 7 hours, so t equals 7, there are 151 bacteria. So that would be here in the b of t spot. So we have these two data points. And now let's remember, ultimately what we want here. Our goal is we want to get a formula for b of t. And it needs to be an exponential model. So it'll look like a times b to the, I'll write t instead of x because it tells me it's a function of t. So I want to figure out this formula. So let's use our data points to plug into here. So for example, if I plug 2 in for the t, because 2 is a t value, we'll get a times b squared. And I know that if we plug 2 in, the output's supposed to be 83. So this needs to be 83. So similarly, if we plug 7 in for the t, we'd get a times b to the 7. And when I plug 7 into my function, the output's supposed to be 151. So 151. And this gives me two equations. So the top one I'll call equation 1. The bottom one I'll call equation 2. So now, is there something nice I could do with these equations to try to solve for my variables? At this point, I want you to pause the video. Pause it for about 2 minutes. And think about what you might do next to try to solve for the a or the b. 4, 3, 2, 1, pause the video. Pause the video for about 2 minutes and see if you can solve this. What we actually have here is a system of equations. 2 equations, 2 unknowns. So this is an algebra problem at this point. Alright, so hopefully you've done that. Hopefully you've paused the video for about 2 minutes to think about this. If not, go ahead and do so now. So let's talk about this. Okay, so what I'm going to do with these two equations to get some stuff to cancel is I'll divide. So I'm going to do equation 2 divided by equation 1. And by doing that, we will end up with ab to the 7th divided by ab squared on the left. On the right-hand side, I'll get 151 over 83. So the a's are going to cancel here. The a, capital A, whatever that number is, will cancel. And I'll get b to the 5th equals 151 over 83. So if I fifth root this now, I'll get b equals 151 over 83 being fifth rooted. Okay, so it doesn't look great, but sometimes the numbers aren't going to look great. So I have b equals this. And let's try to do everything here without a calculator. So let's not plug this into a calculator to figure out what it is in decimal form. Let's see if we can keep going and determine a now. So now that I have b, what would I do to get a? Well, I can take my value and plug it into either equation 1 or 2 to solve for a. So let's plug it into the top equation just because I have a smaller power for b there. And if I do that, I'll get a times this fifth root, so 151 over 83 being fifth rooted. That's b, and then I got to square that, and that's going to be equal to 83. Okay, so now I'm kind of running out of room here. Let's move it up to the top of the page and keep going with this. All right. Okay, so what we have is we have a times, I know I have a big squared. And within that, I had the number 151 over 83 being fifth rooted. But a fifth root is the same thing as a 1/5 power. So we have this whole thing equals 83. So now we have a power to a power, and now power to a power means we multiply the powers. So we get a times 151 over 83 to the, so 2 times a 1/5, that's 2/5, equals 83. And I'm actually one step away from isolating for the a. We just divide by this whole fraction being 2/5, being raised to the 2/5, because that's just some number. We get a equals 83 divided by that whole thing, divided by 151 over 83 to the 2/5 power. So let's just recall that we were trying to write a formula for b of t, and b of t has the form capital A times b to the t. Now we know what a is, and we already solved for lowercase b. Lowercase b was 151 over 83 fifth rooted, or that whole thing to the 1/5 power. So I just have to plug in b and plug a in to this formula for b of t. Okay, so let's do that. So we get b of t equals, let's first write what a is. So a is going to be, so let's first write what a is, and a is this. So that is going to be 83 over 151 over 83 to the 2/5. Okay, and now let's write the b to the t part. So here's what b is. So I got to plug that in where the b is supposed to be. So whoops. So doing that, I will end up with 151 over 83 to the 1/5. But that whole thing needs to be raised to the t power. Okay, so I have this 1/5 power and then a t power. I have a power to a power, so I need to multiply them. So we have b of t equals, copy the first part again, 83 over 151 over 83 to the 2/5. And then that multiplied by 151 over 83. And then 1/5 times t, that's t over 5. And that is our equation right there. So notice, even though the numbers weren't super nice, by keeping them in this form, I was able to do the whole problem even without a calculator. Okay, so there's a short part B to this problem, so let's talk about that. How many bacteria were there initially? So when it's talking about initially, what time is that referring to? Initially means t equals 0. So let's plug 0 in for the time. And if we do that, we get the 83 over 151 over 83 to the 2/5, and then times 151 over 83 to the 0 over 5 is just 0. And then that whole fraction being raised to the 0 power, that's just going to be 1. So we end up with just 83 over 151 over 83 to the 2/5. And there are units here. The units are bacteria. So there are this many bacteria. And if I wanted to round this, or if I wanted to know what this was as a decimal, this is approximately 65. And I'm just going to go to 5 decimal places, 33089 bacteria. At this point, we have done our first goal here. We've found an exponential model, talked about how to do that, that fits given data points.